it's kind of interesting moving on in the chapter. They talk about file systems for a few pages and then they head back into the operating system. So I'm not real sure what the theory is behind here, but let's go ahead and talk about file systems. In the Microsoft world, the two different flavors that you have for file systems are FAT, which is the file allocation table. It was created forever ago. That was what DOS was based on. That was the file system implemented in DOS. That has been expanded to FAT16 and FAT32, and 32 gigabytes is the largest drive that you can use with the FAT file format. FAT is inherently insecure. You don't see that very much in corporate environments. You'll see it a lot on thumb drives or portable devices. You may need to go ahead and reformat those so that you can actually use something more than the 4 gig, especially if the device is larger than that. Standard Microsoft installations are going to use NTFS, which is the New Technology File System. This is very granular, and if you happen to take ITS 210, which is the desktop file system, we spend, golly, I think 2 whole chapters talking about all the different permissions that you have between NTFS and then share level permissions. One thing to keep in mind with NTFS is that each file and each directory has its own access control list. And so you can have an incredible amount of control in setting what kind of access people can have. Where it used to be called the Network File System, and then now they changed it to Network Storage Services, or NSS. It has the same type of granularity. There are some differences in terms of inheritance, but you still have as much control as you'd like to have. It may not be quite as easy to implement, and actually it's been such a long time since I've had to run a NetWare environment, I don't remember if it's easier or harder than NTFS. The textbook also covers Unix and says that it has the same level of granularity at the file level, the folder level, and at the subfolder level. There is a cousin to the Unix file system, and it's called the Network File System, or NFS. And this lets you mount Unix volumes on remote systems. If you've taken the server classes, you'll see that when we install the file system role, one of the options we have is to install NFS, and the purpose of that is if we do have Unix-based files or file volumes, that we can mount those and make those accessible to regular Microsoft Windows users. I think one of the smartest things that you can do to monitor your file system security is to find a utility, doesn't matter if it's free or if it's something that you pay for, that will scan your file system and will identify all of the rights, actually file system permissions, that are assigned. Sometimes, this can be kind of tedious work, but if you run this routinely and you know what you're looking for, you have a baseline, you can tell if something looks different and if all of a sudden somebody's got permissions to file system areas that they shouldn't have, or permissions to the root of different volumes, or something that's going to trigger a flag for you. In addition to using this to kind of check your file system access rights, it is also helpful in case you have some sort of a catastrophe and you lose all of the permission assignments. Let's say that you're moving data from one physical drive to another, or one server to another, or one network to another. You can try to pull over those access control lists, but sometimes that doesn't work correctly. And so if you have a backup of that, if you have a listing, it's not going to be quite so difficult to go back and recreate whatever permission structure that you need. The book takes us back for just another couple pages to talk about updating your operating system. And they've got a couple things listed here. They have hot fixes, they have service packs and support packs. Their definition of a hotfix is something that is used to make repairs to a system during normal operation, even though they might require a reboot. And the example they give is a hotfix may entail moving data from a bad spot on the disk and remapping it to a new sector on the drive. I think in Microsoft terminology, a hotfix is something that has not undergone thorough testing. You used to have to call Microsoft, and it was always someplace up in Canada that you would call. You would have to describe your issue, and they would have to make sure that the hotfix seemed appropriate, and then they would go ahead and send the fix to you. They had a real big caveat that said, this has not been regression tested, we don't know what its full effect is going to be. If you can wait, if at all possible, go ahead and wait until we've incorporated this into a service pack, or unless it's out in a regular maintenance cycle. Sometimes it could take months for a fix to show up in a service pack or in regular maintenance, and so I went ahead and put these hot fixes on. But that is a little bit different than the discussion that they have here. Service packs and support packs, that really just depends on who's packaging them, but it's a collection of known fixes. And the advantage of using this is that they have been tested together. You still have a window of opportunity. You may have something unusual that none of the beta testers have ever run across, and so you still could have some compatibility issues. But when a service pack comes out, for the most part, it's been tested pretty well. However, I will say that I have had to work with several Windows 7 boxes. Service Pack 1 finally came out, and I'm getting a bunch of boxes that get partway through the service pack, and then all you get is blue screen. And I've had to back that out. Seems like there are several known instances of that sort of thing happening. I said earlier that hardening is generally going to be working with software. There is a section here that talks about hardening your network devices, but physically you're not going to actually do anything physical to these boxes. What you're going to do is you're going to update the firmware. You're going to go into the configuration utilities and turn things off, turn things on. It's still going to be a software-based set of tasks that you're going to be working with. I think one of the most important things that you can do is stay current on firmware. Again, you don't want to be on the bleeding edge, but I would give it 6 weeks, maybe 4 to 6 weeks. If you don't see a whole lot of traffic in discussion forums about how cruddy a particular update is, then it's probably safe to go ahead and put it on. I know that whenever I call in for support, either to SonicWall or to Barracuda, the very first thing they say is, okay, you're out of date on your firmware, so let's get that updated, and then let's take a look at whatever you've got. So go ahead and stay current on that. That would be my recommendation. Whenever you get a new device, make sure that you spend some time poking around these configuration screens so you know what the defaults are and you know what's going on. Most devices will come with DHCP enabled. Unless you need that, go ahead and turn that off and hard code static addresses there. That way you don't have the opportunity for another device to come in and grab a valid IP address that somehow could compromise your system. Another recommendation that I have is to make sure that you cycle power to those devices routinely. I think maybe every month or so. Go ahead and power those down, power them back up again. Just make sure that they come up correctly. Sometimes you'll get devices that appear to be functioning well. The lights are still on, they're indicating a good state. But there's been some sort of a power hit, and so even though they look like they're on, they're not actually running well. And especially after there's been any kind of a power hit, even if you've got these on a battery backup, make sure that you come back in and cycle power to those devices fairly quickly after you've had an outage like that.